Hi, okay, so a brief introduction. My name's Alex, and I'm a senior software engineer at Imperial College. I've worked in a number of different organizations of various sizes, actually, and I've seen really variable code review practices, which I think vary a lot according mostly to the attitudes and personalities of the people within the teams, but also broader organizational and cultural practices. So I want to offer up some motivation for doing code reviews as well as some tips for doing them well. Out of interest, who here has a regular code review practice? Okay, good. So about half of you, but a lot of people are not doing code reviews. So a brief introduction to why you want to do them. So what is the motivation for doing code reviews? Well, the first thing is that they're extremely effective at finding defects in your code. It's really simple, but it's incredibly true. So these are some examples from a book called Code Complete by Steve McConnell. So in one software maintenance organization, about half of one-line changes were in error before they introduced code reviews. When they introduced code reviews, only 2% of those changes were in error. So that's a massive reduction in defects just by introducing code reviews into your organization. Similarly, okay, this one is a comparative study. So 11 programs developed by the same set of developers. About half of them, about 5, were developed without reviews. The other 6 were developed with reviews. When you compare the programs at the end, the first 5 have an average of 4.5 errors per 100 lines, and the 6 that have been under review have only 0.82 errors per 100 lines. So again, a massive reduction in defects when you introduce code reviews. And finally, another organization, large organization, 200 people, reporting a 90% decrease in defects after introducing reviews. So it's pretty consistent. We're seeing like an 80 to 90% reduction in defects just by introducing code reviews, which is amazing. And so that's a really measurable kind of motivation for doing code reviews. There's other things which are a little more amorphous, a little harder to measure, but I think still really, really important. Okay, so the first one is learning opportunities. And this goes two ways. So on the one hand, if you submit your code for review, you're likely to get a lot of really helpful comments back from your peers. So I'm right now coding in Python, which is a new language for me. And every time pretty much I submit a code review, I get a bunch of helpful suggestions from my colleagues who are more familiar with it. Things like libraries that I wasn't aware of, helpful utility functions I didn't know of, maybe just alternative syntax options or terser syntax that they're throwing out there. So I know that I learn a lot from those code reviews. And it also goes both ways. So you learn from reading other people's code. I'm a self-taught developer. I imagine probably many people in this room are. And we will have learned a great deal from reading other people's code. Well, reviewing your peers is a great way to just spend some time reading other people's code. You might see a neat way of doing something that you hadn't done before. You might discover a new function, a new style. You'll just develop your coding skills in general. And this applies not only to junior developers, but actually I think to developers at all levels. Future-proofing your code base. So again, this is a little bit hard to measure because by definition, if the payoff is in the future, it's really hard to measure it at the time of implementation. But what do I mean by future-proofing? On the one hand, you can increase your bus factor by having other people, multiple people, look at code. The bus factor, for those of you who aren't familiar, is the number of people in your organization who would have to get hit by a bus in order for your project to fall apart. And actually, I really, really hate this terminology because if one of my colleagues was hit by a bus, I don't know about you, but the last thing I would be thinking is, oh, thank God someone else knows the code base, right? So I prefer to think of this as your Hawaii factor. So this is, if one of my colleagues or how many of my colleagues would have to win the lottery and take a wonderful early retirement in Hawaii for my project to fall apart. Okay, so you can increase your Hawaii factor. You ensure that code is readable. This is obviously super important for future-proofing again, because the developers working on a project are going to change over time, and you want to make sure that anyone can step into this project and get up to speed and dive into that code without massive overheads. And maintaining code standards, again, an incredibly amorphous aim, but something that's incredibly important as well. So whatever the best practice that you bring into your, as we've seen in the previous talk, there's obviously many debates over best practice and code standards, but whatever those standards are that you adhere to as an organization, a great way, an important way of enforcing them is through code review. And you can also, through code review, also explore and develop those code standards as they change over time. Okay, so back to that really measurable thing, defect finding. There's a few simple things that you can do to make your code reviews more effective according to that metric. And this graph comes from a study that was done by Cisco Systems in conjunction with IBM. I've taken this from a blog post they wrote, so I don't actually have access to the underlying data, but they have some nice illustrative principles that they themselves drew out of the data. And the first one is really intuitive. I think you'll probably all recognize as soon as you see it that fewer lines of code are easier to review. And in fact, what they found is that under 400 lines of code, you find a lot more defects. So this y-axis up here is defect density. So it's not the total number of defects, but it's the number per 1,000 lines of code. Okay, so this is a sort of standardized measure, regardless of the size of your pull request, the size of your code review. And basically what you can see is that as these get, I mean, the important thing to note is just that as these reviews get longer and longer, but especially after 400 lines of code, the number of defects found massively drops off. So why is that? Because the reviewer simply can't digest and is probably overwhelmed by that amount of information. And I think it looks like from this particular study, it looks like 400 is a reasonable cutoff. There's other proxies that you could use for this. It's not always obvious how many lines of code are in a code review. So maybe number of files changed is a sort of heuristic that sometimes works. You could say, oh, have 10 or more files changed in this code review? Maybe that's getting a little big. Maybe I'm going to find that hard to review. Making sure that code reviews are single features or single units of work. They don't comprise multiple unrelated changes in one code review. That's also very much related to this idea of pull request size. But size is a really critical consideration. This is quite related and from the same study, and this is the speed at which you review those lines of code. So again, if you review things too fast, you can see that there's quite a steep drop-off in the amount of defects that you actually come back as finding after around the 500 lines of code per hour mark. So if you have one of those 400-line code reviews, you want to be giving that about an hour. If you're doing it faster, you're probably not reading it thoroughly. You're probably not going to find the defects. This one is so another tip is to use checklists in your reviews. This is a really simple idea, but I know that I only started doing this really recently and it's made a big difference in my organization. So these could be at an organizational level. Perhaps you have a standard checklist of things that you want reviewers to look out for when they're reviewing code. They could also be something you could implement on a personal level. So if you know that there are certain things maybe that you are prone to forgetting or overlooking, maybe you want to just enforce this, create a checklist of your own for people who are reviewing your code. These are some super generic ones that probably work for a lot of people. Things like, are there unit tests? Did you understand this? Does it follow solid principles, if those are the principles that you adhere to? But obviously these are going to vary according to organization. I wanted to give you an example because, as I say, we're actually doing this at Imperial. So this is an example of a pull request. We are using GitHub for version control. We do all our code reviews via the GitHub pull request mechanism, which is a great interface. And this is a repository for, so I'm an engineer, but I actually work with research scientists. And those scientists are writing code, but they're not very familiar with agile processes, with version control, with any of these workflows. So we got them to start storing some of their code, reports they were writing in a mathematical programming language called R, inside a Git repository. And we wanted reports to be reviewed as they were checked into this repository. And initially, when we introduced this, it seemed like it was mostly a formality. So these things were just getting approved, checked in, and we were having problems like weird names that didn't make sense, or code that doesn't compile even, or code that doesn't run. So this is a super, super simple checklist that we use in conjunction with a very structured pull request. So we have report name, link to our issue tracking software where you have a description of what the issue was, instructions for running the report, things you want the reviewer to look out for, and then this really basic checklist. Is the name sensible? Is there only one report in this pull request? So relating back to, is there only one issue in this pull request? Does it run locally on your machine? So you'd think these things are really obvious, but as soon as we introduced this, suddenly the review process started making sense, and we started catching these things and saving everyone a great deal of time. Okay, so all of those things are really practical suggestions, thinking of code reviews as basically a task that one person undertakes. One person sits down and reviews code. But what code reviews really are is a dialogue between two people, between an author and between a reviewer. More than that, what code reviews really are is a critique of one person's work, right? So the author submits their work for critique. Now, if someone is invested in their work, which I assume that most of us are, and we hope that everyone in our teams are, then that critique is going to feel personal, because it is personal. It's a critique of someone's work. And I think that bearing this in mind can massively improve your code review process, and it's very easy to forget. Here's a highly unscientific sample from my Twitter followers, where I asked people how often that they feel defensive when receiving a code review. You can see that a couple of people actually said that they never feel defensive, and I think that's remarkable personally, and I'd love to know more about the factors that mediate how people feel about code reviews. I suspect, personality, how well you get on with your coworkers, how long you've been doing it, how well you're invested. There might be so many reasons that mediate this. But basically, the takeaway message is that pretty much everyone has experienced feeling defensive during a code review. I imagine that's very common. I imagine everyone can relate to that, whether it's because they've had an abrasive reviewer or someone they just didn't get on with, or whether it's something that they feel very regularly, maybe it's something they feel in a new job particularly, or what have you. I think this is an extremely relatable experience. I want to offer some explanation of why. So the endowment effect is, I don't know if anyone's familiar much with behavioral economics. So the endowment effect is a phenomenon that's been observed time and time again in psychology and behavioral economics, where people actually value something that they own more than something that they don't own. It was coined in this paper where basically half the participants were given a mug and half of the participants don't have a mug. And then the experimenters wanted to see how highly, in monetary terms, people valued this mug. And it turns out that when you own a thing, you value it a lot higher than when you don't own it. So you can see nearly double in this experiment. This is the price in dollars up here. So people who own the mug were seen to value it at nearly twice the price of people who didn't own the mug. Obviously, there's not a direct analogy between ownership in the sense of owning material things and ownership in the sense of authorship, which is kind of the relevant sense that we're thinking about code in. But really, I just want to illustrate that, if we can't even come up with an objective value system for something as trivial as a mug, the idea that we could objectively value code and that whether we had written it and whether we owned it in some sense didn't come into the equation doesn't seem likely. I'd say it seems likely that ownership in the sense of authorship is an even more profound effect on how much we might value that item and how defensive we might be of that item. So there's another reason that people might feel defensive in code reviews, and this is that they might worry that they're actually being evaluated on the basis of the comments they receive. So, developers might think, for whatever reason, that a lot of comments on their pull request is a comment on them as a developer, or is even going to affect their standing in their job, is even going to be like a formal evaluation of their performance in the eyes of their employer. Moving on to the sorts of things that I think can generate conflict in a code review, and why I think code reviews can be a source of conflict. I've sort of developed this thinking where I categorize things along two axes. So on the one hand, comments can have high reward. On the other things, comments can have quite low reward. And on the vertical axis, things that have a low potential for conflict and a high potential for conflict. So I'll talk first about this upper left quadrant. I've categorized this as pedantry, because that's, I think, how it can sometimes feel to an author when they receive 10 comments pointing out that their indentation was with 2 spaces instead of 4 or whatever. So things like minor typos, white space indentations, or also arbitrary preferences, which leads me to the most relatable slide, I think, for me, which is there's always going to be multiple equivalent ways of doing things that don't particularly matter, don't particularly affect the performance or the logic. They don't reflect some higher design principle, but people have these arbitrary preferences, and it can be very frustrating when you've submitted what you think is great code and someone picks apart these apparently pedantic complaints. On the opposite quadrant, down in the low conflict but high reward category, this is kind of coming back to those defects we were talking about earlier. So I characterize these things as factual, like, oh, you're missing a test for this functionality, or you've implemented the wrong behavior through some misunderstanding, or there's a bug in this code. I think these have quite low potential for conflict precisely because the ownership there is low, right? So someone hasn't made an active choice to introduce a bug or an active choice to implement the wrong behavior. So they don't feel like a sense of ownership over that code. That's just a mistake, and they're probably quite grateful for you to point it out, that they've forgotten to write a test or whatever. And they're high reward, obviously. You're finding defects in the code. And finally, the most interesting category, these are the things that are both high reward and have high potential for conflict. So these relate back to that more amorphous category that we talked about at the beginning of benefits. So code standards and maintainability and scalability and future-proofing. So these are things like, is this code readable? What design pattern did you choose? Is it over-engineered? What were your naming choices? And I think these are categorized as opinion because basically two competent, reasonable developers can have a legitimate disagreement over these things. And because these are active choices that people have made, these are also things that people feel quite a high degree of ownership over. And they probably, just by virtue of the fact that they've done it a certain way, they're probably going to be quite defensive of that way. And yeah, there's sort of, you can see that there's a lot of debate in scope for this. So, you know, even something like duplicated logic, well, there's always a trade-off maybe between never duplicating logic and keeping code readable or keeping logic close to where it's used. So these are things that I think are really reasonably up for debate and really worth debating and worth ironing out through code reviews. There's one more thing I want to point out here, which is something that can elevate conflict is just volume. So even though maybe one or two of these pedantic or one or two of these obviously factual comments might be well received, I think when there's a deluge of comments, it can generally raise people's defensiveness levels. So I mean, one way of reducing that is back to the first slide, which is keep your code reviews small and manageable. And I have a few more suggestions for minimizing basically unnecessary conflict, because you don't want to waste your conflict points on things like typos, when really the interesting conflict that can conflict's quite a loaded word, but let's say the interesting disagreements can happen up in this quadrant. So kind of we want to save all our conflict resolution energy for the things like readability and design choice and engineering choice. Okay, so minimizing unnecessary conflict. Have clear code conventions. So if you come up together with a set of coherent code conventions that you want to adhere to as an organization, and you can implement those right off the bat, you're going to minimize the number of disagreements that arise at the code review level. Automate things that can be automated. So not everything can be automated away. I think some of those more interesting questions need human input. But things like white space absolutely can. So I think earlier Prettify was mentioned, and there's Prettier was mentioned, and there's many linting tools and automated formatting tools that we can employ that are just going to take that pedantic set of comments sort of out of the picture, basically. Unit tests can obviously catch bugs and wrong functionality. So, you know, a strong tradition of always using unit tests can catch a lot of defects. Continuously integrating your code in a build server that maybe runs some of these things as automatic build steps. Again, just means that the code that actually reaches code review is just going to have less of these minor defects or minor issues that a reviewer might pick up on. And author reviews first. So this is, I'm surprised by the fact that some people don't actually do this. So if you review your own code, the surprising thing is you can actually be quite a good reviewer of your own code. I can't sort of count how many times I've created a pull request, gone through to annotate it, found like a rogue console log, or found that I've checked in an erroneous file that's not even meant to be there, or yeah, I've reverted some setting that needs switching back or whatever. So the process of writing some comments on your own code, actually going through and annotating it and pointing the reviewer in the direction of the bits that you think are new, that you think are interesting, that you think merit debate, can be a really effective process at weeding out some of those defects that are just going to be annoying, just going to add to your annoyance level when you get this deluge of comments back. So thinking back to so hopefully we've minimized the amount of conflict that's going to arise in this pull request, but there's going to be things we're going to disagree about. How do we manage these disagreements in a productive way? So one thing that I found really helpful is thinking about the different styles people actually have for resolving conflict. And these are the sort of 5 archetypes in traditional conflict resolution theory. Obviously, it's not to say that everyone fits into these exactly, or that these aren't malleable, or at different times, at different contexts, people don't move between these. But broadly speaking, we have avoidant of conflict altogether. So I definitely know people who either don't like to submit their code for review, or when you ask them for a review, they just okay it straight off the bat and they don't provide any comments. I think one possible explanation of that could be that they don't like conflict and they're avoiding it. Yielding, on the other hand, you might have someone who basically never pushes back and just implements anything off the bat that's suggested by someone else, and that's also not super helpful if you want a collaborative process. Competing, I've also witnessed this, and I'm sure many people have witnessed this, where people see the code review as actually a battleground where they have to defend their initial instincts or ideas, and it's a bit of a playground for people's egos, and I think that can be a big problem. Compromising is kind of like a sort of middle ground that people go down, and then the optimal solution that we want is a collaborative attitude. So we want people to participate in active discussion. We don't want them to shy away from it, but we also want them to understand when they might be wrong, see things from another person's perspective, and really be interested in the end result as opposed to any kind of sort of individualistic ideas. So there's, as well as making your code reviews more effective, of course, and making the outcome of those questions about code standards more productive, there's of course another reason that you might be interested in these conflict resolution ideas, which is just that you want your workplace or your team or your open source team or whatever context it is, your community, to be like a nice place for people, right? Like for people to be generally happy and for it to be a welcoming environment. So of course there's putting efficacy and the bottom line aside, there's also just this, just a good human incentive, I think, to try and think about these things. How do we move people towards a more collaborative style? Basically, there are two main strategies. So one is that we want to lower defensiveness. Another way you could think of this as lower proprietariness a little bit. So I talked about how people feel a lot of ownership, and that can lead them to value things in a little bit of a distorted way. So lowering proprietariness a bit, lowering defensiveness on the one hand, and raising ego if someone is always yielding or is very avoidant of conflict. So giving people a little more confidence, giving people a little more assertiveness. What are the things that we could do to get there? So on an organizational level, pair programming is a great strategy. Does anyone here pair program at work? Cool. So that's one thing that can be used. Used to foster a sense of collective ownership. Basically, at the end of the day, it's not just one person who's written that code. So the authorship is shared and the ownership is very explicitly shared. It seems really basic, but discussing things prior to implementation. So if you are going to embark on something that's going to be a novel way of doing things, or maybe you're introducing some logic that's never been seen before in your code base, that you might be implementing new coding standards, just discuss that collectively before you implement it so that these decisions are taken forward as a team. Never silo code bases. So don't have one developer working on one project, another developer working on another project. Mix and match. Keep your developers moving between the projects. Work in small units. Basically, again, this is a way of reducing a sort of unhealthy level of ownership over a particular code base. This is kind of abstract, but the more you feel like a team and the more you've built those team relationships, the more receptive you're going to be to your teammates' feedback, basically, and the less defensive you're going to be. And finally, back to that idea of being evaluated, make sure that you do decouple any individual performance metrics from the code review process. So you don't ever want your developers to think that their performance within the team and as a developer is being assessed on the number of comments they get back on their code, because then you'll end up just with a dysfunctional process that people don't want to participate in. Okay, what can you do as a reviewer? One really basic thing, say thank you to the person who submitted the code. It really goes a long way for people to feel that their efforts were appreciated. Even if you have a lot of comments about the code itself, their effort has not gone unnoticed and you're appreciative of the effort. Another principle that I think is right is to aim to raise code only by a grade or two. Don't overreach. So if you do have a junior developer or someone whose code is a little bit below what you were hoping when it gets to code review, try and nudge that grade up. So if it's a C grade code, try and bring that up to a B or maybe a B+. If you're getting B code, try and raise that up to an A. If you try and drag someone from a C to an A+ or a D to an A+ in a code review, that's going to be a really painful process for everyone. So training, although code reviews are a great platform for learning, training is something that should happen aside from code reviews. And the code review process has to be kind, and it has to be something that people want to engage in. And that's not going to be the case if they feel that they've basically scored an E. Ask questions. So this is a simple language thing. I think I missed one thing. OK, so the first thing I wanted to say, which has disappeared from this slide, is changing you to we. So I'm already doing that here. So you could say, you could reuse this function, or you should reuse this function, even worse. And a much nicer way of conveying the same message is, we could reuse this function. Even if the person, even if you're talking about something that person, the author, is going to implement themselves, just say we. It's really simple. Every place you say you, say we. Phrase things as a question. Could we reuse this function? I mean, firstly, it sounds friendlier, and secondly, you might actually be wrong. Maybe you've overlooked something. That author has been looking at that logic a lot more intently. Perhaps there's some subtlety in those functions that you haven't realized, and it can't actually be reused, or they have a good reason for not reusing it. So phrase things as a question. Justify requests. So again, this is making a request rather than a demand. So instead of saying, rename this function to get reports with formatted date, something like, could we rename this to get reports with formatted date, to make it clear that the date will already be formatted? So I'm justifying it, I'm phrasing it as a question, I'm inviting the author to respond, I'm inviting the author's opinion effectively. So these are some strategies that we can use just through our language as a reviewer. Oh, there you go. The other thing you can do as a reviewer is be positive. So give some positive feedback, even if it's just a one-line comment, which is thanks for writing this, or this works really well, or this works perfectly, this is just what we wanted, or whatever. But I usually find there's maybe like something positive to comment on the code, basically. Even if it's like, this is really easy to read. Well, that's a plus. That's great. Comment on that. Readability is one of the things we're looking for. Don't take it for granted. Say thanks. Say that it was good. It sounds really simple, but at the end of the day, we're all quite basic creatures, and we all have these egos, and telling people that they've done a good job when they've done a good job really goes a surprisingly long way. OK. Again, my slide is messed up. I'm obviously not very good at this. OK, so as an author, what can we do as an author? Because it's all very well giving all this advice to reviewers, but at the end of the day, sometimes you will receive reviews from people who are difficult, or phrase things in an abrasive way, or say things that are hurtful, or just for whatever reason, it rubs you the wrong way. So some strategies that you, as the author, as the recipient of the code review, can employ. The as-if technique, which is a little challenging, but very effective. You just imagine that you were something else. So you could imagine that you were in a different state of mind. Like, how would I respond to this if I were actually grateful for this feedback instead of wanting to flip the table? How would I respond to this if I were Mary? She's always so calm and magnanimous when she receives critical feedback. What would Mary say? How would I respond if this code wasn't mine? If I was reading these comments about something a third party had written, how would I assess the validity of the suggestions that are being made? So it sounds kind of simple, but it's actually a very effective technique. Say thank you to the reviewer. So it goes both ways. The reviewer has spent, hopefully, as we saw, at least an hour reviewing your 400 lines of code. So say thank you to them for their time. That can be disarming to them. It can make them feel appreciated. It can make them engage in a more good faith with you. And it can also be a way of practicing this first one, right? So the second you say thank you, even if you weren't feeling grateful, maybe you feel a little more grateful. Annotate your review first. Again, I mentioned this before, review your own review basically first. This can be a way of making sure that the reviewer understands your intentions, engage them, get in there with the collaborative engagement first effectively. Or if someone is not really, this is also a way of if someone is reluctant to participate in the process, someone has that more avoidant style, you can sort of solicit their feedback and show them that you really value and you want their collaboration. OK, so summary. Optimize reviewer effectiveness with a few simple tricks like checklists and like small self-contained pull requests. Minimize unnecessary conflict, automate away things like white space arguments. Understand feelings of ownership and don't really expect people not to feel feelings of ownership. That's just human, that's just natural. And furthermore, it's probably not desirable to get rid of feelings of ownership. People who value something highly also take pride in it, also put a lot of effort into it, also care a lot about the merit of the outcome. and nudge people towards collaboration, whether you're the organization at an organizational level, whether you're a reviewer, or even if you're an author, you can try and nudge your reviewers towards collaborating with you. So that was really dense. Thanks for sitting through it, and hopefully you can all take away some of those tips to implement in your own code review practice.